Hello everybody and welcome to math class. In this lesson we are going to be doing a lot of rules. So this one is one of the more difficult lessons in this book, and in my opinion I'm going to be teaching you a lot of new things here. So hang with me. This may be a long one, but we'll break it up into pieces if it is. I've already put a title down for my next page. This is called Identify and Generate. Generate means to create equivalent expressions. So if you need to pause your video and write your title, that is fine. You need item 3 of your memory pieces. Mine is colored because I need to be able to refer to these. You can color yours if you want to, or you don't have to. It's entirely up to you. You need the factoring flashcard, and then you need these two pieces: multiplying binomials using FOIL and factoring out common terms. So if you read the lesson overview in Schoology, you've already pulled these pieces. You should already have them ready to go. So what I'm going to do is to give you the rules one at a time, and then we're going to practice those. So you'll need some blank sheets of paper to do some practice problems. I thought about giving you all the rules and then practicing, but I think it will help you more if we practice as we go. So you'll see what I mean in just a second. Alright, the first thing, we normally start with flashcards, but this time I want to start with item 3. The cover, which is green to me, the properties of operations, we don't have to do anything to that. So we are going to actually start with the associative property of addition and multiplication. So let's turn, mine is yellow, it's this piece right here. If you find your piece that looks like this, only yours is not yellow, let's look at what this associative property means. Okay, here's the rule. Let me get a different pen. You can group add-ins for addition and factors in any way you want and get the same result. And here are two examples. Let's say that I want to add A plus B plus C. And I like to put practical words with this. So let's say that I'm adding some apples, some bananas, and some cookies. I can add the apples and the bananas first and then add the cookies. Or I could add the bananas to the cookies and then add the apples. It will not change the result. Those two things, those two processes are equal. The same with multiplying. I can multiply A times B and then multiply C, or I could do B times C first and then multiply A, and it will not change the result. I am not going to ask you on a test to write this down. What I'm interested in is you understanding the concept, what the rule is telling us that we are allowed to do. Also, you may have children or grandchildren who come home with this type of thing, and I want you to be able to explain it to them so that you're able to understand it so you can explain it to them. So let's do some practical examples. I'm going to turn over to my next blank page, and I'm going to write the name of the rule. It is the associative property of addition and I'll have to just put a comma. I can't fit and in there. Multiplication. And let's look at some examples, some practice problems doing this. And I have to get over to mine so I know. Okay, let's take as our first example 3 plus 5 plus 7. This is an expression. So I'm going to add the 3 and the 5. That would give me 8 plus 7, and that's going to give me 15. So let's do it the other way. 3 plus 5 plus 7. Let's add the 5 and the 7 first. 5 and 7 make 12, and 3 plus 12 is 15. So the two sides are equal here. The order doesn't matter as long as you're adding because you're building up. And I'll tell you what, you don't have to do this, but I'm going to change mine. I'm going to take off the multiplication and just write it down here. So here's an example of the associative property of addition. Now I'll give you the associative property of multiplication. Again, I'm not going to ask you to write the rule or anything. I just want you to understand the concept that I can change the order and it doesn't matter in terms of the answer. So here's a problem with multiplication. Let's do 5 times 2 times 6. And I'll do it on this side too. We're going to do it two different ways and see if we get the same thing. So here I'm going to group the 5 and the 2 first. 5 times 2 is 10. 10 times 6 is 60. So on this one, I did the 5 times 2 first. On this one, I'm going to do the 2 times 6 first. And 2 6s are 12. And then 5 times 12 is 60. That is the associative property of multiplication. This was the associative property of addition. Okay. All right, let's go back to this one. Let me flip back in my notes, and I need the pink one, the commutative property of addition and multiplication. And you should have your line up there. Not sure what happened to mine, but it should be there. Okay, so here's the rule on this one. You can change the order of add-ins and factors and still get the same result. This is very similar to the one we just did. Okay. A plus B is exactly the same thing as B plus A. A times B is exactly the same as B times A. Same thing. The order doesn't matter because you're building up. So let's look at some examples of the commutative property of addition. So, commutative property of addition. And property just means characteristic in this case. Commutative property of addition. And let me look at my examples that I've done. I did 12 plus 15 should give me the same answer as 15 plus 12. So let's see. Let's compare the two sides. 15 plus 12 is 27. 12 plus 15 is 27. So yes, the order does not matter. Let's check one out with multiplication. So this is the commutative property or the commutative characteristic of multiplication. And for this one, let's do 5 times 6, which is 30, is exactly the same answer as 6 times 5. It doesn't matter about the order because you are building up. So there are some real life examples of those properties. Okay, going back, I want to look next at the distributive multiplication. So for me, that's this blue piece, distributive multiplication. And for this one, I'm just going to give you some examples here on the card, and then we'll do some more over on the examples. But let's start with this one. 5 times 6 plus 3. 5 times 6 plus 3. So I'm going to multiply the 5 times the 6. That would be 5 times 6. And then the 5 times the 3. And then I need to finish the math. So I have 5 times 6 is 30, plus 5 times 3 is 15, and that gives me a simplified answer of 45. This right here, those arrows, that is the process of distribution. You're distributing the 5 to the 3 and the 6. And we call that distribution. Okay, let's do one with algebra. Let's do A times B plus C. So this one doesn't have numbers, but the process doesn't change. You get A times B plus A times C and algebraically you want to get rid of the times sign, so you would have AB plus AC. C. So you can use distribution. Again, that's this process. When I say distribution, I want you to do this process. You can use that with numbers, with constants, or with variables, but the process does not change. Okay, let's look at some examples of distribution. Let me get to my pages. I always make notes before I meet with you so I have something to go from. This is called, let me use the right, distributive multiplication. I told you there's a lot in this lesson. Okay, so here's one example. I'm going to give you two examples. Let's do 3 parentheses 6 plus 5 plus 2. So I'm going to multiply 3 times 6, then 3 times 5, and then 3 times 2, and simplify. 3 times 6 is 18. 3 times 5 is 15. And 3 times 2 is 6. And then you add all of those up to get 39. Okay, that is distributive multiplication. So let me show you what happens if we add a variable to this situation. So I'm going to do 3m times 6a plus 5b plus 2c. So let's do this using variables. And I'm going to need all the space I can get, so let me slide that back. Okay, so we follow the process. 3m times 6a. And I'm going to write it this way. So there's 3m times 6a. And then 3m times 5b. And then finally 3m times 2c. Okay, so I have distributed the 3m to all terms. But now we have to simplify. So let me zoom in here and I'll show you how to do this. It's not as bad as it looks. Let's do this one first. 3m times 6a. 3 times 6 is 18, and I have an a and an m. We actually have an m and an a, but you need to put those in alphabetical order. So you multiply your coefficients. 3 times 6 is 18, am. Okay, this one I'm going to do 3 times 5 to get 15, and then b and m. You want those in alphabetical order, and you can bring that plus sign down. And then on this one, I have 3 times 2 to get 6, and then c, m in alphabetical order. And that's as far as I can go. I have distributed the 3m to all terms. That's pretty advanced stuff there. If you're understanding that, you are doing great. Okay, we have one more rule in that flip file. So let me go back to that one, and that is distributive division. So let me show you what this one looks like, and then we'll do some examples. I'm going to show you 3 examples here. 2 of them with numbers and 1 of them with variables. So here's the first one. 6 plus 8 over 2. So that's saying 6 plus 8 divided by 2. That is the same as 6 divided by 2 and 8 divided by 2. 6 divided by 2 is 3, 8 divided by 2 is 4, and that gives us a final answer of 7. So we're distributing that division to both terms. What if we had 10 minus 6 over 2? So we could break it apart and get 10 over 2 minus 6 over 2. 10 divided 2 is 5. 6 divided 2 is 3. 5 minus 3 is 2. So let's look at one with variables. Let's do A minus B over C. So we could break that up to get A over C minus B over C. But that's as far as I can go because I don't know what to substitute for my variables. This is called distributive division. And let's look at some examples. I'm going to do 2 examples for this one also. So here is distributive division. So first example, parentheses, 25A plus 10B, close parentheses, divide sign 5. And you may be thinking that looks nothing like what we just did. But it really does. Because if you write this using algebra, you have 25A plus 10B, and that division sign becomes that fraction bar with 5 on the bottom. Those are exactly the same things. The bottom way is the proper way for algebra. So then I'm going to distribute my division. So I have 25A over 5 plus 10B over 5. So I break it apart. And then we need to go ahead and simplify as far as we can. And let me just follow the form that I used. That's going to keep us consistent. So this first one, look at this. What is 25 divided by 5? Well, that's 5. And it has an A with it. We don't want to lose the A. What is 10 divided by 5? That is 2, and it has a B with it. So you can go ahead, there's that 2, and then here is that 5. You can go ahead and simplify it down as far as it will go, but then you can't go any further with the 5A plus 2B. Okay, here's another one. Another example. Let's draw a line. I don't want these to run together. So I have 64A squared in parentheses plus 16a plus 8a close parentheses divided by 8. So the first thing you want to do is write this algebraically. You want to take your parentheses and put those as your numerator. And you can drop the parentheses because we're making a double decker here. You don't have to keep them, or you can if you want to. It doesn't matter. And put your 8 on the bottom. That divisor becomes the denominator. So let's split them up. We have 64a squared divided by 8 plus 16a divided by 8. They're all sharing the 8. That's the distributive division. You're distributing that 8 to each of those terms. And then let's simplify. Let's do this one. You have 8 into 64. That goes 8 times, and you bring down the variable part. And then you have 8 into 16 goes 2 times, and you bring down the variable part. And then you have 8 into itself, which is just 1 time, and the variable part. But we're still not quite finished, because we can simplify a little bit more. What could I combine here? What's alike? These two. 3a, and then this one, a squared and a are not the same thing, but I can at least combine those two like terms. Let me highlight that for you. This part gives me this. Okay, distributive division. So we are ready to put this color piece booklet together, and I showed you how to do that in the video, the assembly video, so I'm not going to spend time doing that here. Just go back and watch that assembly video, and it will show you how to put this piece down into your notebook. The next piece I want you to find is this one. Multiplying binomials using FOIL. And when you get ready, I want you to go ahead and stick this piece down wherever you want it to go. You just glue it down. And I'm going to do an example with you right here. First of all, I want to explain the title. You know what multiplying means, but binomials, let's define that term. A binomial is an expression with two terms. Bi means two. Okay, so binomial is an expression with two terms. So m plus 5, that has two terms, m and 5. And then m plus 8 has two terms, m and 8. And we want to multiply those two terms, those two binomial terms, together. So we use a process called FOIL. And you notice that FOIL is in all caps. That is because FOIL is an acronym. FOIL helps me remember a process. FOIL stands for first, outside, inside, last. F-O-I-L, FOIL. And anytime you have to multiply binomials like this, you have to remember FOIL. And here's how it works. Let's start with first. So I look at my terms and I see that m is the first in this binomial and m is the first in this binomial. So you take the two first terms, m times m, because remember we're multiplying binomials, and that is m to the second power. M times m is m squared. There's my first terms. Then let's do the outside terms. So we've got m on the outside and plus 8 on the outside. So we have m times plus 8. So that is plus 8m. Those are the outer terms. Inside, I have a plus 5 and an m. Plus 5 times m. So plus 5 times m is going to be plus 5m. Those are the inside terms. And then the last two terms, you've got a plus 5 and a plus 5, a plus 5 and a plus 8 are the last terms. And that's going to be a plus 40. No letters in that one, just a constant. And so I have foiled my problem. And I am getting low on my battery, so I'll fix that in just a second. The next thing we need to do is to combine like terms, and that's going to be right here. You see those m terms? I have 8 plus 5, that's a total of 14 m's. 13 m's. 8 and 5 make 13. So here is my final answer. M squared plus 13m plus 40. Because these two combine to give you this one. M squared, that's this part, plus 13m plus 40. And this is called the product of those binomials. This is not easy. Foiling is, I love it. I think it's fun. Once you get the hang of it, it's a lot more fun. But it takes a while, and it is not a simple thing to understand. If you hear noises, I am plugging up my iPad to charge. I'll keep working, but if I don't plug it up, it's going to cut off on me soon. We don't want that. Okay, let's do some more examples of foiling. So I'm going to turn over to a clean sheet, or you can just put your examples. Actually, that would probably be better. Just to go ahead right under your picture or where you have room. Let me do it this way. And keep those examples with the rule. I'll do 4 more of these. We'll practice 4 of them. So the first one is going to be x plus 10 that's the first binomial, x minus 3. Now I didn't want you to have to cut out so many things, so I didn't give you the piece for this one, but you can sort of make your own. Just come down through here and write FOIL. And then we have first. So the first terms in each binomial, the first term is an x. So I have x times x, and that equals x squared. Then outside, I have an x and a minus 3. Outside, or outer, if that helps you. Think of it as the outer ones. So this is going to be a minus 3x. Inside is plus 10 and x, the inner terms, plus 10 and x, that is plus 10x. And then the outer terms, you have 10 and negative 3, plus 10 times negative 3, and you can use your calculator to do those negatives if you need to, but positive 10 times negative 3 is negative 30. And then you need to combine like terms, which would be these two. If I had 10 x-rays and I lost 3 x-rays, I now have 7 x-rays. We're ready to put this product together. I have x squared plus 7x minus 30. Excuse me. I feel like I'm getting sick. I hope not. So this is the product of those two binomials using FOIL. Okay, let me draw a line here, and I'll give you three more examples of FOIL. Here we go on this one. So I have a plus 6 times a plus 9. And I need to remember my acronym FOIL. So I have first, that's going to be a times a, which is a squared. Outside, the outer ones would be a times positive 9. So that's plus 9a. Then inner would be plus 6 times a. And last is plus 6 and plus 9. That's plus 54. Then combine these terms if you can. You won't always be able to, but in this case you can. So I had 9 apples, I got 6 more apples. I have a total of 15 apples. So I have a squared plus 15a plus 54. And that is the product of the two binomials. Okay, here's Here's another example. Let's do x squared plus 6 times x plus 7. And we're multiplying binomials, so we need to FOIL. First terms will be the x squared and the x. So that is a total of x to the third power. Outer is x squared times the plus 7. So that is a plus 7x squared. Inner would be the plus 6 and the x. So that is plus 6x. And then the last pieces of each parentheses would be the plus 6 and the plus 7. That is a plus 42. So this time when I go to combine these, I can't, because they are not like terms. You cannot mix an x squared with an x. So in this case, there is no combining. You're going to have x to the third plus 7x to the second plus 6x plus 42. So this product has 4 terms. The product has 4 terms. And let's go back and look at that with these. In this first one, the product has 3 terms. That's called a trinomial. You're multiplying binomials to get a trinomial. This product has 3 terms, so it too is a trinomial. And I'm not sure if you would call this 4-term one a quadrinomial. I'm just going to call it a polynomial. Polynomial is anything with more than 1. So we can use polynomial for any of them. And that's not important right now, but it will be later on, so it never hurts. We're not ready to do a flashcard for these terms, but it doesn't hurt to go ahead and start using them when we can. Okay, one more example of FOIL. Let's do m squared minus 3 times m squared plus 6. And I do first, outer, inner, last. So first terms in each binomial would be an m squared. So that's an m times m to the 4th power. Outer, I have an m squared and a plus 6. So that's plus 6m squared. Inner, I have a negative 3 and an m squared. So that's negative 3m squared. And then the last two, I have negative 3 and plus 6. And that's going to be a negative 18. Use your calculator if you need to do that. So check to see if these can combine, and they can. So you have 6 subtract 3, that leaves you with 3. m squareds. So here's the final answer. M to the fourth plus 3m squared minus 18. That answer, that product has 3 terms, so we call it a trinomial. Look at this vocabulary that you're learning. It's pretty impressive. And you have learned how to multiply binomials using FOIL. This is a good HiSET skill. Okay, we have one more rule to talk about, and we also have a flashcard. Let me just pull that flashcard over here with its rule. Maybe. Yes. So the first thing we want to do is the flashcard. Flashcards don't get stuck down. So let's go ahead and put this. The word is factoring, and then you turn that over. And here is the definition of factoring. Factoring is dividing all terms by the same amount. And that amount is called the factor. So this is the opposite of foiling. In foiling, we're building up. In factoring, we're breaking down. We're dividing all terms by the same factor. And here is how it works. Let me move my flashcard back out of the way. Whoa, I don't want to do that. Goodness. I should have left it on the first page to start with, because let me just pull it back over here and leave it where I had it, and then we will have it out of the way. Okay, so here is the piece that you need to glue down. Wherever you want this rule to sit in your notebook, go ahead and paste it down for me, or tape it, whatever you're doing. And let's look at how this works. And here is the trinomial. It has 3 terms. So let's use the proper terminology. This is called a trinomial. And this is how you factor. Step 1, you look at all the terms and ask yourself, what do all, in this case, 3 terms have in common? 25a squared, 15a, and 5. So you have to think about this. What is it about those 3 terms that is common? And here it is. All, let's not do it that way, all can be divided by 5. So the common factor is a 5. Then you divide the first term by the common factor. So you have 25a squared divided by 5. 5 into 25 is 5 times, and that also leaves an a squared. So I'm just dividing the coefficient by the 5. And then you have 15a divided by the 5. So I can say 15 divided 5 is 3. And I still have the a. And then this last one, be careful here. A lot of students get tripped up right here. 5 divided by 5 doesn't just go away. What is 5 divided into itself? It's not 0, it's 1. So you are factoring out the 5. And here's how you put this problem together. Let me go ahead and highlight this last term. You take the common factor first. So you bring it down here and you put it down, and then you start parentheses. It's very important because you can't just do away with the 5. That 5 belongs to all of those. So we have to bring it down here. And then you start to list your answer terms. You have 5a squared that you got from the green part. And then you have 3a that I got from that blue division. Where would I be without highlighters? And then you have the plus 1 that you got from that constant division, that yellow step. And then you want to close your parentheses. So you have that common factor of 5, and then those simplified pieces inside your parentheses. Okay? It's not an easy skill to see. You have to really practice these. And let's do that. Let me give you some examples of factoring. And I'm just going to put mine right under here. So the first one, I have 12a squared plus 4a plus 2. So I have to ask myself, what do all those terms in this trinomial have in common? Well, the answer is that I can divide them all by 2. So my common factor is a 2. So I'm going to divide my 12a squared by 2, and that gives me 6a squared. And then I'm going to divide my 4a by 2, and that gives me 2 into 4 is 2 times. That's 2a. And then I'm going to divide my 2 by 2, and that gives me a 1. So to put together this answer, I need all of those pieces. I need the 2, the common factor, and then I need the 6a squared plus the 2a plus the 1. Let me highlight those for you. There's the common factor, 6a, 2a, and 1. And so my answer is there at the bottom. Okay, let's do another one. Let's do 100 m to the third power plus 10m to the second power plus 10m to the first power, which is just plain 10m. So ask yourself, what do these have in common? Well, they all have tens, and they all have at least one m. So my common factor this time is 10m. So I'm going to say 100 m to the third over 10m. 10 into 100 is 10, And if I take an m off the top and the bottom, that leaves me with 2 m's on the top. So m squared. Okay, then we're going to divide the 10m squared by 10m. 10 into itself is 1 time. m2 minus m1 would leave me with just 1. And then finally, I have 10m over 10m, which is going to equal 1. So to put this answer together, I need all of these pieces. So I'm going to have 10m as my common factor, 10m squared plus 1m. The test will not use the 1, but you can put the ghost 1 if you need it, plus 1 in parentheses. And this is called factoring. Okay, one more, maybe 2 more, since we have space. 32ab plus 8b plus 4a. Actually, let's make this a 24a. So I ask myself, what do they have in common? Well, I could divide them all by an 8, but they don't have any letters in common. They don't have exactly the same letters, so we can't do any letters. But the common factor is going to be an 8. So then I take each piece. I have 32ab divided by 8 is going to be 4, and then you keep your AB. Then 8b divided by 8 is going to be 1, and you keep your b. And then 24a divided by 8 is going to be 8 into 24, that's 3 times, and you keep your a. So I have all the pieces of this puzzle that I need. I just need to put the answer together. So we have an 8, a 4ab, a single b, the test will not show you the 1, and then the 3a out there. Okay, one more, and we'll let this go. Let's factor. I'll have to make one up because I only made up 3. Let's do 5mz plus 15ma plus 25m xy. So we need to ask ourselves, what is the common factor here? Well, all of them are divisible by 5, and they all have an m. So we can take out 5m from each term. So here is 5mz divided by 5m. So that leaves me with just a z. (15) MA divided by 5M. The m's cancel. So 5 into 15 is 3 and an A. And then 25MXY divided by 5M. So the m's cancel. 5 into 25 is 5, and we still have the xy. So now I have common factor and then 3 more terms. And we have 5m, z plus 3a plus 5x y when factored. Okay, there is a workbook page on this lesson, so we'll be practicing all of our skills. You'll be using these skills throughout the algebra course. Watch these examples as many times as you need to. That's why I broke them up by rule. So if there's one particular rule that's giving you trouble, you can go back and watch just that section. Remember that your instructors are always there to help you if you have questions. I will see you soon, and I hope you have a really good day. Bye-bye.